Hi, and welcome to a new episode of the AI Workflows podcast. My name is Frederick. I'm the co-founder of ZDeck, an AI software for creating professional presentations, and the host of this podcast. And I'm excited that today we're recording our very first episode in English. Yeah, AI is transforming many industries and professions, but perhaps no field is being reshaped as fundamentally as software development. When I was in high school, people used to say, study something in IT, go into software development. It's a future-proof career with strong demand. Today, the picture looks very different. AI is automating large parts of the development process, and many people in the industry are asking themselves what the future will look like from here. In this episode, I have the opportunity to explore exactly that question with two very interesting guests. Firstly, Robin Pokorny, Senior Staff Engineer at Atacama, a platform that helps companies reach and maintain data quality, and organizer of different meetups, including the React Berlin meetup. Great to have you in the podcast.
Hi, Frederick. Thank you. I'm happy to be here.
And we have Phil Bennett, former Director of Engineering at the health tech company Kilo Health and Engineering Leadership Consultant at Punk Leadership. Thanks for joining today.
Not a problem. Great pleasure to be here.
All right, let's start with the first question. Let's continue with what I just mentioned. What would you actually tell a young person that is thinking about what career they should decide for? Do you still think that learning how to code is a future-proof job choice? And what should these people keep in mind when they make that decision?
I think if anyone stands up and tells you they have the answer to that question and is 100% confident about it, they're probably wrong. I think everything is changing so fast and so dramatically that it's currently a really difficult question to answer. I think there is a high possibility that the answer to that question is no, go and do something else, go and do something creative and more human. But also there is a potential that these things are opening up much larger possibilities and maybe, there is even more opportunity for doing things related to software and software engineering in the future. But anyone who answers that question confidently is probably not looking at the full picture to make their assessment.
Makes sense. Robin, what do you think?
I mean, I still think it's a good career choice, I would say. And I mean, as Phil said, like nobody knows what's happening. So, I think it's as good as any other almost in these times. So I would still say it's, if you feel that you hear the calling, let's do that. You should definitely continue. But it's different than it was 5 years ago, which was different than it was 20 years ago, which is different. It was 100 years ago being an engineer. So yeah, things are changing and they will change as well.
Then let's take a look at exactly that. So what is actually changing about the day-to-day work of an engineer right now, Robin?
I think that the most visible thing is that people use AI. I mean, that's what we discuss here. But what they do is that they don't write code anymore much. That's what I observed, is that code is now being generated by the tools. And that can be on various levels, meaning people do something that we call wipe coding, meaning they only prompt the high-level requirements and then something pops up and they hope it works, which is mostly used for prototypes. You can bring an idea to something tangible very, very fast. Some people use it for production, which is something we still are not so sure about. And then you have something which some people call AI-assisted engineering, meaning you kind of still review the code. You treat it like somebody else, like maybe a junior or some other senior was helping you writing the code, and you consult it. You have AI get you analysis and do large form refactorings that were really annoying and cumbersome before. So now you can do it much faster.
So in the end, you could say that AI is also taking away a lot of the things that software developers didn't like doing in the past, or is it then that the job is also becoming a bit more attractive by that?
That's a good question. I think that it depends what you liked about being a software developer. If you liked being right, if you liked caring about some minuscule things and code style, then no, like this is kind of not the great part. But if you like building something and having something, solving problems, solving user problems especially, then yes, this makes it much more easier for you.
I think what's really interesting in this space is that for decades, software engineering has been very expensive. Like hiring software engineers is expensive. The process is slow and complicated, so it takes time. And what has happened in that space of time is it allowed people to think about, we've thought about software engineering as a craft. So it's like, oh, I really care about the details of this because it's expensive and we need to make sure that we get things right first time. And what that kind of has done is I feel it's kind of bred a profile of engineer who is like super into the craft of it. Like any kind of making or creative endeavor, there are lots of people like, right, I want to make the best version of this thing for all of the sorts of reasons. And there are some valid business reasons for doing that. If it is functions better and is more performative or is more reliable, then great. But then what is now interesting to see is the cost of software engineering has just fallen through the floor dramatically. If you want to build software cheaply, you can do that at a reasonable quality now. Quality is still, I think, a little bit under question. It is massively improving, is definitely what we know. And then that kind of starts to challenge that profile of an engineer. Like the people who really cared about the craft can still do that, but how much value there is in that is something I think we're going to have to try and work out over the next couple of years, but it might be the next couple of months even.
It's quite interesting. I have heard a philosophical podcast about this topic a while ago, and they were saying it's interesting to see how while work is automated more and more with technology, you can also observe how people are under more time pressure increasingly. So I think it's going to be interesting to see if the AI technology is really going to take away that pressure from the developers and freeing up this opportunity to become more creative, or if people find themselves running behind more deadlines than today.
I think that the difference is that here everybody has access to it. Like, meaning it's not something that it's something special that you obtain or you have to work very hard to get. So because it's available to everybody, it's not a competitive advantage. And I think that it's normal in the sense like electricity is normal. So it will be, a tool. It will be something that you use, but it doesn't give you that option to, I don't know, work half time and like live off that. No, that's not going to happen, unfortunately.
So yeah, I think this is the answer to that question. I think is going to be driven by business, really. Like business wants to, like capitalist endeavors generally try to get the most financial gain out of any situation, right? So if engineers are able to produce more things that are creating more value, they'll be doing more of that. Whether that is really the case is to be seen. Like it might be that we kind of hit plateaus and stuff in terms of what engine, like in certain areas there's only so much of something you can do, right? So let's take marketing for example. Like you may only have a certain audience that you can market to, so you can't actually, there's a limit that you hit. There's only a certain number of people who buy your product, and then there'll be plateaus in terms of what we build, what we can build, what people actually need, and I think and what can be sold, and I think that's probably going to drive how utilized engineers are going to be in the foreseeable future. And I can't predict a really good outcome for that. Like we may invent things to sell, to build, right? But I think, I don't know. I think it probably will plateau, and then that's going to do one of two things. Either companies will allow people to innovate and test, and we'll kind of go back to maybe where we were about 15 years ago with software engineering, where companies like Google had like 20% time, right, where people could play around and do whatever they wanted to with technology, to looking for those kind of innovations. Or companies are going to look to save money by downscaling engineering teams, and that's going to be potentially what will happen. And I think probably, if I'm going to make a guess, it'll be a mix of those two things. Some companies will err on invention and testing and playing around with this technology, and others will just cut people to make the profits.
On the question of how the job of software engineers is changing, are there any specific tools or even interfaces that you guys see emerging? For example, is it a thing to use voice-based prompting to write code now?
No, I mean that was one of the big things for me. Like, I mean, I like to talk. It has always been better for me to talk than to write. So yeah, it's like I do that. Like my working now is like I switch on the whisper flow. You know, I sit like this, hands behind my back, and I dictate, and I like do a brain dump of like what I want to talk, all the context, all the important things I think that it should think about. You know, all of that I put there, and I read it, and and it's there. It's just a huge information. I believe that giving this context is the important part, so that's why I like that, and it's much more easier to do that by using voice than typing it out.
I'm not like I don't have the same experience. Like I'm not like I think this is a little bit around how people's brain works and how they interface with certain things, because we've had this, there's been differences in this for a while in software engineering. Some people will use more graphical interfaces, some people will move more towards CLI. There's still people who use a very old piece of software called VIM, and that's very text based, and that's just how they work. And my brain, I think, works slightly differently. If I start talking, I just nonsense comes out, and I think I always find I'm dyslexic, so writing is hard for me. So I have to put this kind of filter in place to get things down in writing, and then it's kind of filtered to be the output that I really, really need, because I've had to put some effort into doing that. So I just don't find I don't find speaking into these tools particularly helpful for me. I read it back and I'm like, no, that's not what I was thinking at all. That's just the stream of consciousness that is not really helpful to anyone. And maybe I think the interesting thing potentially is that now it's much easier and cheaper to build these things. Maybe I can just prompt with that kind of stuff and see what comes out, but it might not be entirely useful.
I think that there's obviously a huge FOMO. Like, you hear about people, I don't know, swarming, I don't know how many agents at once, and using that great tool, and there's so many buzzwords around. So, I mean, I don't know how to navigate it myself. What I do is like I'm curious but conservative. Like I chose some tools that I use. I know that they are improving. I don't necessarily chase the most, I don't know, the most recent thing. I usually, it's like you wait a few weeks, and you get it anyway. So this has been evolving. But maybe one thing I saw is that at the beginning, when I say beginning, it's been like 2 years ago or something, right? When Cursor came, people were using Cursor, like this idea. You have an IDE that you can talk to, and I've seen a small shift when Claude Code came, where it was originally more terminal based, like CLI based, and it was independent of the editor, and it could do like different things. And I personally feel that now that second thing is more prevailing. But I mean, obviously, the number of people using both approaches is like through the roof. So it can be biased, but that's what I at least saw.
Yeah, I definitely see the same pattern in terms of people moving, and I find it kind of really fascinating that we're kind of going full circle back to CLIs, which was really how we started writing software and interacting with machines. I see a lot of people moving towards that, and even non-technical people moving into CLI based tools, which is really, really interesting, I think.
That makes a lot of sense. We're in our team, we're always thinking about when we think about where can we use AI, it's always for things that either take a lot of time and are very repetitive, or things that no one really likes doing. And in terms of software development, one thing that really falls into probably both of these buckets is documentation. So we're really looking into how can we use AI for that. Is that something that you see in the teams that you're working with as well?
I think there's something quite interesting about the AI and the documentation topic, because AI is still very non-deterministic, and in documentation that starts to become quite a lot of a problem, because as humans we tend to not read stuff a great deal. So what we are kind of presented with documentation that looks right. So we say, right, we need to create the documentation. We will use AI can you document the code base? Can you write a summary of what's going in here? And we look at it, we go, yep, that looks right. That's sensible. And we don't know until we actually try and use it whether it's actually accurate or right. And that's, I think, a real problem with AI generated documentation. I've seen and spoken to a few people who had real problems where they're like, when they've actually come back to it, when it's, we know when the incident has happened and they've gone, right, oh, we need to try and understand what all this code that the AI has written is. They go to the documentation. It's like, this is just a massive hallucination and none of it really makes sense. It looks right at the time, but really we don't know what it is. I think that is improving, but I feel that there's still potentially always going to be a risk of that. It does solve one major problem with documentation, is that, like, historically what's normally happened is documentation has been right once and then never come back to again. But it being much easier to update is going to be helpful, because a lot that we still had that problem before with documentation, that when someone comes to actually use it and need to use it in anger, it just wasn't up to date. So it still was also just as useful as AI generated hallucinations. So maybe there's some benefit. I think this is a topic that's maybe to be confirmed. I think a little bit, like I've seen both sides to this a little bit, but documentation is always something that everyone's always really struggled with. So maybe this helps.
I mean, I agree with Phil, like about the external documentation, like something that's like outside. What I want to talk more about is like the inline comments, which AI is famously adding a lot of. And that can be useful. I mean, sometimes it can overdo it, I guess. But, it is really nice that it documents the intent of the code. And this kind of brings me to think that we knew that the whole time. Like, we knew that documenting intent is what we should do. And we knew about some other things, like, about some approaches, like, test-driven development, like specification-driven development. We also knew about domain-driven development, like all these ideas. We knew they work for humans. And then we still kind of ignored them as an industry, or at least didn't use them enough. And I have a feeling that now when you have something that so clearly benefits from these approaches, when you have it write tests first, when you write specification first, and then you have it implemented, when you think about the product, about the intents, all of these things now, it's very tangibly useful. That's what I see. And so people take these things we knew are good from the very beginning, but now they are becoming more widespread in general.
Who do you think the document's being written for, though? Who is AI writing the inline documentation for?
Sure. And I mean, there's the same thing as, when you have a Claude MD or Agents MD, it's useful. Like, I mean, but we knew that, like, we had READMEs for humans. Now we have Agents MDs for agents. What I'm trying to say, like, the content of that, I very often saw READMEs where this is a project, and then there was some outdated steps how to run it locally, which didn't work. So I think that having something that, as you said, is like being up to date, and it helps others and helps human or digital agents, then that's beneficial.
Although I wasn't trying to make any specific point, it was a genuine question about the, like, I'm still not, still a bit unclear about what the purpose of this documentation is.
No, like, I mean, you have code which doesn't have the whole picture. You have to add the storytelling. You have to add the intentions. You put that in writing, because that's the best way we know right now. It's there somewhere, and then how you query that information back, either through coding for an agent or prompting, like, meaning querying the data, like the repository, like, asking chatbot, like, is this repository doing that and that? How it gets the information, that's not important, but having documented is useful.
Another area for which I hear a lot of people using AI is testing. What's your experience in that field? Are you seeing any new opportunities how we can build tests with AI?
TDD is really, test-driven development is really coming back in a big way after becoming a little bit unpopular over the last 4 or 5 years. But I think defining the specification in code and saying, look, this is the acceptance criteria, is now really easy to do. Like, that's one thing that AI is very good at, is writing these acceptance tests, because they are very sort of procedural and they kind of go through a list of things. And then writing to those specifications really helps, because you've got this, how a lot of their agents are working is this kind of iterative approach. It's like, try something, oh, it doesn't work, try something, it doesn't work. If they've got the test, they'll know when they've hit the endpoint and the goal much easier and much quicker. So yeah, I think testing is really coming. Not, I mean, testing's always been there, right? But this kind of, like, the concept of writing a test and then writing the code has become more more prevalent. It's also how Claude code itself is mostly written by the team who writes Claude code are very big into TDD, and that's generally how the whole platform has been built.
Yeah, I think that AI is useful on both sides, meaning I can do something like TDD where I have the test first and I use a test as a guardrail, some boundaries for the code. And then the agent can kind of explore solution within those boundaries. That's like one part. And I can do it separately, so I can, make sure that tests do what I want, what is my intention, and then have the code fulfill that. On the other hand, we've seen AI being used to write extra tests. That's like we've been doing that for end-to-end testing, where you have something that clicks in the browser and tests your application. Now you can have this being to a certain extent automated, to have an agent who uses the web browser, clicks around, understands what's happening, and it to a certain extent do explorative testing, to a certain extent to really fulfill some critical business flows. We've seen some tools that do that, and maybe the outcome is a good old playwright script, but having something else write these tests, which are notoriously boring to do, and people are kind of been avoiding writing them, so you have more coverage and more confidence that things work. That's been also helpful.
Yeah, I think it's really interesting to see how AI can be used for testing in general. I have rather a background in UX design, and when I'm designing UIs, I sometimes just take a screenshot and send it to an LLM or to ChatGPT or something like this, and ask it, okay, what do you think you're supposed to do here, or which button would you click to do something? And it's really interesting to get that feedback, and oftentimes I get really interesting insights how I can improve the interface. So all these kind of design and development cycles, they get much quicker. You can be much more iterative and get to a much better result in the end.
I think this speed of iteration topic is a lot of where the real power in this stuff comes. We can iterate much quicker with this technology, and it's not just in the code. It's in in the product side of it. All of these kind of things, we can just go through these loops much quicker.
And I want to touch on one thing that you kind of mentioned, is that using AI as a devil's advocate, like having it review the code, having it like ask the questions that you don't think of. And that's one thing I also been using it for, is like, where would this break? What is the limitation? What's against the standard patterns, like how people use this technology, especially when you are not used to this. So it's not only about writing the code. It can also, I one of the things I very often write, let's say architecture decision records and documents and review these, is to have deep research. Like I've been working with APIs, and you design an API, and you're like, okay, so how do people solve asynchronous non-atomic tasks? What is the API they usually use? And you have something that will go through a large number of standard APIs, some famous ones, and then it will come with a really nice report, and it says, okay, people use this and this and this, and it's like, okay, like this would make sense for us. I can like at least look into that. This would take me hours to go through, and I would probably got distracted by something else. It would really take me some time to get that knowledge. But now I can have a really comprehensive report, and then use my I would call it taste, and we can talk about it more, to select something that will fit our purpose.
That's a great segue to what I wanted to ask next. So we have a good understanding now how AI is changing the profession and the workflows of software engineers. So the next question is, what does a software engineer need to know? What do they need to be capable of doing in the future to be a good software engineer? Robin, what do you think?
So I think that we move by level in a way. What I mean by that, and that's kind of what people describe it. And this is not technically correct. It's just like the mindset's changing. Like you would work with junior engineers, as your agents would be junior engineers. And what this requires you to do is to do something we call technical leadership. It's sometimes called staff plus engineering. I read an article that said every engineer will become a manager now. I think that's not the right direction, but the idea is like there, you don't deliver things by on the individual level, but you need to understand how you can separate the task into smaller pieces, have them independently maybe developed, evaluate them. As I said, know more about product. Like product thinking is something, and we've been talking about. We had product engineers and all that, but understanding product, understanding business, understanding the outcomes as opposed to outputs, all of this will become more and more important, because the level below can already do things you did before. I hope it's making sense now. But yeah, I think that you need to think more strategically on a little bit higher level. Maybe, you can call it architectural level, like so many buzzwords you can use there. But the main idea is split things into small pieces and not focus on one singular atomic thing that you can deliver. Unless that one thing is super, super important. And it's always been the case about, speed. Like most of the times you don't care about how fast things are until it's a critical piece, right? Until it is a problem. And then maybe you will need a really deep expertise that you can't get from AI right now. And you might need to hire, I don't know, external consultants, whatever. But it's only for these specific bottlenecks where you will need to invest more.
I think what's really interesting though, Robin, is that a lot of that stuff that you're talking about is experience-based knowledge, right?
Yes.
Like all of that stuff comes from experience. And it's that kind of, my experience of when I started using AI coding agents, I found that I was quite productive with them because of my experience managing bad engineers. So at the beginning of the process, they were pretty bad. They would make mistakes, and because they're trained on human code, they make the mistakes that the bad junior engineers make. So I kind of had these instincts to know where to look for what was going on. It was like, right, I assume they're going to make this because of the experiences that I've had. And then I think there's a huge question there. It's like, how do you get that experience if you're coming in at that level? Where does that experience come from? Because you're not going to go through all of those pains, all of those learnings, all of those, you build that whole kind of mental context model from your experiences. We remember the things that stick in our brains the best are the things that you have some sort of emotional experiences. And when you're building software, it's generally pain. There's normally the emotional pain of something going wrong and somebody shouting at you because you haven't delivered something on time or something's gone broken in production. And if junior engineers have to come in and they're expected to have all of this kind of experience knowledge already, I just don't know how we get there. Like, I don't know how you jump from nothing to having some kind of grounding in this. It's a big question, and I can't quite see how we make that jump.
We met with Phil, I think last week for lunch, and he knows I'm really like this concept of taste, of what, like, bringing taste into the AI. And just 2 days ago, and I mean, I mentioned it because we talked about it last week, and 2 days ago this article came out, which by Dave Griffith, and it's called "What Do Engineers Mean When We Say Taste?" And it's a really beautiful piece when they talk about this. And what I kind of like is a quote that engineering taste might be the most under-theorized important concept in our field. And they really go into, he goes really deep into what this means. And it really resonates with me. Like, I mean, Phil calls it like experience-based, and then many things is like that. Like, you need to see bad, you need to see good, you need to, kind of calibrate yourself, what it means. So yeah, like that's very tricky to do. And I believe that's where our value will, or still is in a way. It will be for a while.
Yeah, but I just don't understand how I think you could, because you also, I think taste is great because you can kind of model it around in the same way as a musician, right? Like the best musicians are the ones that have listened to loads and loads of music and loads of different variants of music, different genres, and kind of really tested their kind of boundaries. And those are where great musicians come from. So it's kind of like, if you're going in immediately expecting to have, coming in, expected to be this kind of like, concert pianist when you're coming out of university in terms of coding, it's going to be like, we're going to have to really rethink education on this topic a lot. And I don't like, there's a huge gaps of stuff, because also we also know that even when we weren't, or everything wasn't changing every week, educational institutions have always been behind the tech industry. Like, they've always been a decade behind with their teachings. So how we're going to start to get junior engineers out of that pipeline is going to be very, very interesting. And I wonder whether even traditional education for software engineering becomes almost completely obsolete, and it is now much more about taking that more foundry type path. I'm not saying that everyone should be like a startup founder, but like test it, playing around with things, investigating, trying to build your own things, go through that kind of whole process, and actually try and consider it in a business aspect where you actually have to think about what this product is going to do. Is it going to actually be, convert into something useful for the business? Is maybe going to be more important than learning Delphi. That's a long time ago. Delphi University shows how old I am.
That's interesting. And that brings us to the next question that I wanted to talk about with you. With software development becoming more automated, more AI driven, it feels like it also lowers the boundaries of accessing that profession for someone. And we see it also with vibe coding and all these things, that more people are also fascinated by the idea that they can develop their own code, build their own apps. What do you guys think? What is needed actually for people to build good software with an AI, maybe even for people who want to enter this field right now?
I think for me, there's two big things that people really need to think about. And the first one is the objective, the intent. Like, what are you trying to really achieve? Like, and not and get past the product. Like, you could say, like, I want to build a whatever app or whatever. Like, it's like, what is the app meant to be doing? What problem is it meant to be solving? And this is a topic that we talk about for software engineering for ages. Like, let's worry about the problem that we're trying to solve rather than necessarily the technology. So that's a key one, I think, keeping that in mind. And I think people are really beginning to, I see a lot of people losing sight of that at the moment because they're so excited about the technology. And I think we're kind of interestingly going back a bit in terms of like, oh, there's so many fun, cool things to play around with. There's so many possibilities. We've forgotten about the actual purpose of this and the problem we're trying to solve. And then the second one is we're going to have to really rethink risk. And risk assessment, I think, is the other big topic there. The people who understand risk assessment and actually sitting down and saying, what risks do I have when I create this software? How do I mitigate them? What's the doing it's not complicated stuff, right? What could happen? How likely is it going to happen? If it happens, what's going to happen? And how do I make it either less painful or happen less likely to happen? And I think, though, if you have those two pillars of knowledge and understanding when you go into these things, I think anyone can achieve something production ready and great. And the risk, you should, like, if you identify the business risk, the tools should be able to help you understand the technical risk that actually means, right? A lot of people going into this will be thinking about GDPR and data privacy and those kind of things. You just need to be aware of it and understand what risk you're approaching, and the technology should be able to help you. It will help you just as well as software engineers have done in the past on that topic.
We have tools like Lovable and and even the codes can do things like from very little input. I still believe, and I'm coming back to me dictating the context, like you can't expect that, I don't know, 2 paragraphs of text will kind of create an application that will be unique enough to be, I don't know, that you can sell it and stuff like that. Like, I just want to clear it out. And that because the technology is available to everybody. Like, if you were the only one, yes, that would be massive. But because everybody can use that, you need to put more into that. You need to really think about that. And I mean, on the other hand, what I saw is, like, I do like single off applications, one-off applications. Like, I take my SD card from my personal scale, and I can analyze the data from it, and I can have a nice website with interactive elements, and that's cool. I saw that for other things where you would create a report, maybe I don't know, a spreadsheet, but now I can create a nice website, and that's all great, and it's one of the things where I wouldn't invest the energy in. On the other hand, creating applications, and especially large-scale applications handling data, that can be dangerous. We saw that. I don't know if it's still relevant, but I saw one example. There was a website, and it had sign up to the launch newsletter or something like that, and it said join these 120 people, and then in the code it included all 120 emails on the front end because, well, the AI thought it's a good idea. So these kind of things could happen, and unless you can review it and you can trust it, or the risk is really low, as Phil said, this will always be there.
I'm wondering, the whole promise of this vibe coding is a bit that everyone can build their own things and can become maybe a mini software developer. At the same time, you pointed out there are some things that you shouldn't do yourself if you don't know how the technology works, something like data security, very complex software. So is that then an illusion that everyone is becoming their own developer? Is there still things that you want to hand to people who are experts about this field? And is the things that people are building with vibe coding tools not that part of software that the real, in quotation marks, software developers are building? Is that where it goes, or where do you see the development?
I think it's really important to separate like these vibe coding platforms against what's actually possible with AI coding agents, because the vibe coding it has some restrictions to it, right? And that means that you, especially when you come, like they intentionally, right? They put these guardrails in place to kind of try and protect the users, but there are some restrictions, and it kind of makes that technology very useful for concept testing, MVPs, just getting something out to test, which is incredible. Like that's an amazing thing to be able to do. But then it's quite hard to translate that stuff into high performant, high security software. Whether everybody needs to do that is another question, because some applications you don't need to. But then if you start to look at what AI coding agents are capable of, they are capable of everything that a software engineer is capable of. They can do, because everything has moved to being command line based, they can write a database, they can define security protocols, they can do all of those things. It's available to them to be able to do. And it's about, and then if you can connect the knowledge to the technology, it in theoretically allows anybody to build really what we would classify as high quality production software without needing to know the knowledge. They need to have to find somewhere to get that knowledge, but doesn't necessarily need to be from a human being at this point, I think.
Yeah. And what I want to say is that there is no like AI engineering, meaning like something that's produced by AI and something by humans. It's not distinguished. Like there's no line. Like it goes out there. It's a system. If you launch it to other people, it's there. It doesn't matter who built it, how it was created. I think that one part which is scary there is that you can never have a full audit of your application. You can compare it to an article that you get AI to write, and you might be able to read it and somehow find all these hallucinations. The problem with software is that there could be small things that nobody can really see. They can become problems later. And I mean, that's true for human written code as well. I mean, that's always been there. And that's why I'm like saying it's still part of the same social technical system. But it gives you the false illusion that it looks good and therefore it's a good application. That's what I think it could be a problem.
So that means that it's kind of splitting into two parts. There is this area of vibe coding where people have a really easy access. They can build prototypes, try out things, build small applications for their own use, but not for highly sensitive data. And then we said there is this area where you use AI for proper software development. And there the real challenge is to get people to the knowledge and experience level that they actually need to steer this AI and to control the output. Is that what we're seeing?
I wouldn't separate it. I think it's part of one spectrum. And sure, you can go, on one way, you have, I don't see the code ever, I only prompt it. And on the other hand, you can have, it's handmade, and you will create a TikTok video how you crafted code by, basically like somebody today would be punch cards, showing you how that looks cool. You would have that with people writing code. I don't know, it's something like that, like a woodwork. It's so beautiful to see.
Artisanal coding.
Exactly, artisanal coding. You might go to a fair and show how you coded by hand, and people are like, "Oh wow, it's so cool." So that's one end. But I mean, there's so much in between. And as I said, like in the end, it's a system you put out. And when you talk about the vibe coding, like, I mean, we should maybe talk more about experimentation and prototypes, right? And I remember I was on a workshop of UX where we did prototypes by having a big Post-its and a very thick pencil where you draw the UI, and that was all you had, right? And it gave you an idea how the app would work. And then you had more higher fidelity, Figma was there. And now you have even more high fidelity, but you can actually click through it. But you should think if that's still a prototype and you only want to validate an idea, which I think is awesome right now, or if you want to go and put it out there for people to kind of pay for and use.
I guess where I'm still missing the connection is that we earlier said, how you guys said, when you started using AI, you realized what makes you able to use it is your experience as developers and maybe working also with more junior people, and that you see the risk that juniors don't have that experience, so they cannot work with AI. Now we're saying that it's getting really easy for people to get into that field. So is this necessity to have this experience maybe just something that that people needed to have in the early phases where AI was not ready to deliver this high quality code, or is it still an issue also in the future?
I think you can kind of, it's about any kind of knowledge work, right? The most important thing is knowing what is the right question to ask, right? Because we have always for a long time had a world of information available to us. It's now even more available to us. But if you don't know, like, and it's so if you think about the coding model, like if I need to know that my database needs to be performant. I need to know that there is a potential that if I get a index wrong on the database, it could completely crash my whole system and slow it down so that no one can actually use it, right? Like, it's that having that, like, how do you make sure that you know what's the question to ask, what's the thing to think about? And that's why, like, these kind of like lovable links, vibe coding platforms put that into some sort of framework for you. They kind of put the guide rails in place, but it doesn't, like, there's nothing, that information is all there and it is all in the LLMs, right? So connecting it to the vibe coding tools is definitely possible in the future. So we can definitely kind of like remove that thing. But then it's like, and then the big question is then when it comes back to kind of taste is like, where's the differentiator, right? Like, how are you differentiating yourself in any way? Because everyone has access to that technology, and the more we standardize it and the more we create standardized approaches to it, the less differentiator that you have when you are approaching the stuff. And I think that will increase, like, it will reduce the differentiator between someone who's gone to university to study software engineering and someone who just who has worked out how to install Claude Code on their laptop and is now just playing around with it. Like, I think there's going to be very little to differentiate those two types of people very quickly on this regard, I think.
What Phil said reminded me one thing I want to say. It's like, we shouldn't hold too tight to the knowledge we had before. What I mean here is, like, I never written assembler code. I never even written like a proper C code. I don't know how to make a CPU, right? And I mean, at every generation, there were these, I would say, purists who was like, oh, you don't know the principles. Like, that's what I know. So you can't build on a higher level. And maybe that's where we are at as well. Like, we shouldn't hold to say, okay, this is true software engineering, because the software engineering has always been a tool. It's always been just a mean to create something, to create some products. So having people using it on a different level, differently, is not wrong. It's not problem. It just happens that things move on and people move to a higher level as they have several times in the past.
I think it's super interesting because I hear people say similar things from different professions. They say you need to know, like, what kind of questions to ask. You need to think strategically. What are your goals? You need to make project plans, manage your time and your resources. It feels like everyone is becoming a bit more of a generalist, like a knowledge worker generalist who knows all of these things. And I think that's interesting to observe, because I feel like in the past, all of our economy for thousands of years was based on the idea that people get more and more specialized on things, and you have people doing really small parts in a process of a value chain. And now it feels like it's changing. Maybe it's changing, and people take over more. We have this idea that people can run an entire company with just one person. And I can imagine that for young people, it's really challenging, because if you can do everything, then the question is, what do you actually want to do? And you're not really part of a crowd anymore. You can be this thing today and a totally other thing tomorrow.
Yes. Yes, I think is the answer, is my answer to the question. Yeah, I think this becomes incredibly interesting. And I think a couple of years ago, if you'd spoken to about this, I would have been talking about the importance of knowledge sovereignty, about how people maintain control of the knowledge that they have and how we keep a differentiation. I built a knowledge sovereignty platform, was the thing that I vibe coded that no one wants. But it was too late. It had already happened. And I think that's now a really big question. Like, if you can, I think I see a lot. I've kind of been floating around in like founder circles for the past like year or so. And the really interesting thing is about lawyers and legal aspects, whereas most startup founders would have gone, oh, I need some terms and conditions, or I need some baseline legal stuff for this. Now, so many people are just going to Claude and ChatGPT and getting their terms from there. Even, it's a risk assessment that people are making, but it's happening. So there is just a less need for that specialist legal knowledge, and I think that's going to, impact that, and it's going to happen across all areas of expertise. I think people are going to be able to start to utilize that. But how what to do, I don't know. But then there's another compounding factor to this, is that the second you work out what you need to do, 2 seconds later, someone's built the same thing when the second they see the thing that you've done. So it's like, how do you keep ahead of that curve is going to be a very interesting question for us to answer in the next couple of years. We may need to, universal basic income might need to appear a lot quicker than we expected it to need to.
Yeah, super interesting. I want to close with a question that is a bit more practical, because we have a lot of managers, also team leads, who are listening to this podcast. So I just want to break it down to kind of maybe an advice for the next 1 or 2 years. And for software development specifically, what would you guys say? What is an advice that you would give maybe a tech team lead? What should they be looking out for? What kind of skills should they recruit? What kind of performance criteria should they apply to be successful with their team? Robin, maybe you want to take it first.
Yeah, I will start because Phil has that practical experience being in that position. I have the benefit that I can dream about these things. I believe that it should be, again, about the outcomes. What have you changed? How effectively you were at delivering something. And when I say delivering, it doesn't mean like a task, right? It means like really changing behavior of people out there. How helpful have you been? Like all of this is important right now, and how you like achieve that is also important, right? Sorry, it's important in the sense like you should talk about that. You should help others as well. You shouldn't hoard your knowledge. But then, yeah, like if you coded it, if you had I don't know, read articles and now you experimented something and it works, it creates that outcome. I think that's what I want to see things be, is like caring about the outcome, not how it has been achieved in a way. But then, yeah, like I believe that it's still working teams. It's people. You want to be nice to each other. You want to value that. Like being a brilliant asshole is always a bad thing. It doesn't matter if you are very efficient with AI or not.
Yeah, I think right now this is a topic that I'm talking to a lot of engineering leads about. One thing that people are talking about is trying to find people who can really understand the business side of things and the vision and the mission of a company, and really are on board with that, because those are the people that are going to be fairly useful in the short term. And then the other thing that I had a conversation with a couple of people about, which is kind of interesting, that does maybe give some hope for younger generations, is the neuroplasticity of younger people is potentially going to be very useful in the next couple of years. Not being locked into certain ways of thinking, not having a really open, like genuinely really like scientifically open mind to new topics and new ideas, and the fact that things will change, and be really open and excited about that, is probably going to be the one maybe redeeming feature for junior engineers in the next or whatever they might be called, junior members of teams in the next couple of years, because people like myself who maybe are a little bit more stuck in my taste is defined, and my taste may not be valid tomorrow. And already on a couple of topics, my taste is becoming outdated very, very quickly, especially in terms of like how people are leading teams and stuff is rapidly changing. So I think that's the looking for those people who can connect the business dots together and the ones that are just open for change and excited about the possibilities of what might come next. And a little bit like realistic and tiny bit scared also helps.
I realized one thing because I remember you talked about performance valuations, right? And there is this pitfall, I would say, that people can fall into. The same way people were evaluating number of lines of code written, you could be tempted to evaluate, how many tokens you burn, or how often you use AI. And what I want to say is that's not the metric you should look at. Like, I mean, obviously you can look into that, but it's not like the more code you write, the more AI you use doesn't mean that you produce more useful things. So that's just one thing I want to emphasize. And there will be a ton of these false metrics, and there's Goodhart's law, that any metric can be eventually gamed. So you should be very careful about what you evaluate the performance on.
People are measuring token spent as a metric in engineering organizations. I've seen and heard of multiple people. I mean, there is maybe just some kind of justification in terms of trying to prove the acceptance and the transition and ability to move into that kind of thinking. Yeah. But it is very similar to the lines of code written. But people are measuring that. It is something I hear a lot about.
I know, and I mean, I agree that like it can be useful to some extent. Like it's setting things on the right track. Making sure that things kind of move in the direction you want to set. And I agree, like it can show that people are using it in certain ways, but it shouldn't be the primary performance indicator or something like that.
Thank you so much, guys. It was really interesting to talk to you about this topic today. Robin and Phil, thank you very much for joining. We kind of started with a question about how is everyday work of software developers changing and ended with the future of our economy. That's very, very inspiring.
Yeah, thank you. Thank you for having us.
Thank you very much as well to you listeners and watchers on your favorite podcast app or on YouTube for joining in and following our conversation today. If you like the podcast, I'd really appreciate if you give it a like or subscribe our channel. And otherwise, I'll be happy to see you next time again. Bye-bye.
Thank you. Goodbye.
Bye.